This is supposed to be our last video for the week, and we just look at horizontal shifts quickly, then do something else. So horizontal shift, uh, this affects your shift to the right and to the left. So you're looking at left, left and right, right, left and right, right. Okay, so you have f of x, which is equal to, let's say, 2 over x minus 3 plus 5, right? You want to shift this 2 units to the left. So one thing that you should note every single time is if you are shifting to the left, you are always adding. You do the opposite, you add. A shift to the left, you add. A shift to the left, you add. So we are shifting 2 units to the left. Remember we said the horizontal shifts, they affect p, right? So our new function h of x will be 2x. Since we are now adding 2, this becomes minus 1 plus 5. Let's quickly check our asymptotes. So x minus 3 for the initial graph equals 0. So that means x is just 3. The other one, x minus 1 is equal to 0. So x is just 1. If we draw our graphs, your first asymptote was at 3. So 3. Now this one is at 2. Is at 1. So you can see that this has actually shifted to the left 2 units. So that means you are correct by just doing the opposite. Also, if we want to find, say, g of x, which is a shift of 5 units to the right, for this function, this will be, so since it's to the right, you subtract. So this will be 2 over, you're going to subtract 5 down there. So this is just going to be 8 plus 5, right? You can see that 8 is down, it's further the other side, the right side, right? So you could draw that and actually show that it's just 5 units to the right. But yeah, that's just it in terms of shifts. Let's talk about one special translation, which is y equals x. So what does this mean? So this means that if you have a coordinate xy, this quickly becomes yx. So this is a special reflection about this line. So this line crosses here, right? So it's a reflection about this line, y is equal to x. We should have a term for it. We call this an inverse of the other point, right? So you find an inverse of a graph, which is just, you find it after taking the reflection, y is equal to x. So let's do a quick example. Y is equal to x squared, right? In fact, let's say this is just f of x is equal to x squared, right? So this is your graph. We want to find its reflection. Okay. Let's give ourselves a point here and say this is just 2 and minus 4, right? So, oh, what have I just done? This is minus 2 and 4. So you got minus 2 and 4 here. Yeah. If you want to take your inverse for this function, which we actually write in the form of minus, right? This becomes your inverse. If you want to take your inverse, or you want to take the reflection about the y, the point y is equal to x, or the line y is equal to x, to be specific, this becomes y. So you interchange y and x. You first write it like this and then interchange y and x. So x is going to be y squared. That is your first step, interchanging x and y, right? It's your first step every single time if you're taking the inverse. Right after interchanging the two, what you need to do is to make y the subject. So make y the subject. Now in this case, just take that, this becomes y is equal to yes, y is equal to the square root of x. That's just it. There's the inverse. Now we do have our graph here already, so let's try draw this graph. If you want to draw this graph, let's start with our point -2 and 4. Same way as we said this is going to take place. Here we're also going to have that the two coordinates, they interchange. So if you draw your graph, you should have something like this somewhere here. So it means down here you should have something like that. So this will become a graph. Yeah, and our coordinate is 4 and -2. So there we go, 4 and -2. But there's something wrong with this graph, right? If you were to draw a line here, check, a vertical line, it actually cuts our new graph twice, which is definitely problematic. So what we do is we come up with what we call restrictions, and restrict ourselves to certain points, right? So our first restriction will be, what if on our original graph we say our x is positive? So that means we are focusing on this side of our graph, right? Positive. Because we said they interchange. That means for our inverse, our y has to be positive. So if you check our inverse, this is our y being positive. So that will be the reflection of just that one side that you've shown up there. Same thing that will happen with when, say, for our original graph, our restriction is x is less than 0. So this is x less than 0, right? Because x values are negative. That means for our inverse, it's when y is less than 0. So it's going to be just this, just that part only. But yeah, that's just us doing that. What if now you have y is equal to 2x plus 3? You want to find the inverse. So find the inverse. The inverse. First thing first, again, here you're going to interchange your y and x. So this is going to be x is equal to 2, y plus 3. So don't forget, this is you interchanging x and y. Next up is you make y the subject. So you make y the subject. So if you want to make y the subject, you're going to take 3 to the other side. This is x minus 3. 2y divided by 2 divided by 2. Now y is just x minus 3 over 2. Perfect. What if now you have an exponential? F of x is equal to 1 over 2 x minus 1. You want to find the inverse. In fact, let's not have -1 at this stage. Let's just wait here. So what you'd want to do here is this. First thing first, you're gonna write it as like that. Then you start interchanging your y and x. X is equal to 1 over 2 y, right? You want to find your y from here. So because you want to make y the subject, y is equal to, we use logs again, logarithms. This is going to be log of, down here it's your base, which is 1, 2, and here it's going to be just x. So we could write it just like that. So there we go. So that is y. Again, let's take another example here. H of x is equal to 2 to the power x minus 1, right? First, you write it as y is equal to 2 to the power y minus 1. Okay. Why do I have 2 y's? It's still x up there. Then you interchange from here. X is equal to 2 to the power y minus 1. Your next step is to take 1 to the other side because you want to make y the subject. So there we go. X plus 1 is equal to 2 to the y. Now y is equal to log of, our base again is 2, so it's 2 down here, x plus 1. That becomes our new graph. Please make sure that you do get this. One last example, you've got g of x is equal to 2 to the power minus x plus 2. You want to take the inverse for this graph. If you want to take the inverse for this graph, again and again, this becomes y is equal to 2 to the power minus x plus 2, right? Interchange the 2. If you interchange the two, then this becomes x is equal to 2 to the power minus y plus 2. Now you want to make y the subject. If you want to make y the subject, you can just make everything that is up here the subject, right? So it's going to be minus y plus 2 is equal to log again. Our base is 2, so 2 is down there. What have I done? Base is 2, then up here it's just x, right? From here you can make y the subject, so it's minus y is equal to log base 2x minus 2. There's a negative here, so y is just negative log base 2 x plus 2. It becomes positive. One thing to never forget. But yeah, that's just it in terms of taking logs. Our next video will be on an example